In this video, I'm going to continue teaching you inequalities. We now have to learn something called a domain. Before starting, I'm going to show you the answers for the last homework. Please have a look. Now first, let's talk about types of numbers. There are of course more than 4 types in math, but you just need to know these 4 types for now. So, what are natural numbers? As we all know, natural numbers are just 1, 2, 3, 4, 5, 6, 7, 8, starting from 1. Now, what about integers? Integers are, along with natural numbers, all the negative numbers as well. And of course, we have to include 0 here now. And now, what about rational numbers? Rational numbers not only includes integers or natural numbers, but also decimals or fractions. You know how some of the decimals just don't end, but keeps going forever without any patterns? Those are not rational numbers, but irrational numbers. But one exception is, if the decimals are not stopping, but still has a pattern like this, for example, then they are still rational numbers. You probably learned this, but this one, I can write it like this. Like this, a bar on top of the numbers. This means 2 and 3 are the repeating numbers, right? So rational numbers are pretty much the numbers that can be written down. Like this one doesn't end, but we can still write it down like this, right? So including the fractions, decimals, integers, and natural numbers, these are all in the rational numbers category. Lastly, what are the real numbers? Real numbers are basically all kinds of numbers you know. So natural numbers, integers, and rational numbers, and even irrational numbers, which don't have an end. Did you know that square root of 2 keeps going forever without any patterns? It's irrational number. You could check through your calculator. Also, pi is a number, right? If you think about it, pi is 3.14159 . It's a number. So we include pi in the real numbers as well. By the way, pi doesn't have any patterns either. Isn't that cool? I'd like to also show you the symbol of each type of numbers. So this symbol is simply from the natural numbers n, but with a bar. So it looks like a 3D letter, right? Some people also write it like this. Write down n and put a bar like this. So you just have to make it into 3D. Integers go with letter Z. I know it's strange, but that's how mathematicians define, so what can we say? So you just have to write down Z and then put an extra bar like this so that it looks like 3D. And rational numbers as well, for some reason it starts with Q. They probably have some reasons, which I actually don't care about it either. And you just have to write it in 3D as well. And the real numbers are with a bar. You know, I usually write it like this. This is good enough too. So I just introduced you the types of numbers briefly. And you'll be seeing this symbol for the real numbers a lot in this video. Now, let's get back to our topic. Question 1. Write the domain of X and also show it graphically. So we have an inequality here, and we need to figure out its domain. Let's first isolate x. So we've done this a lot. I just have to move -4 to the other side, right? So -3 plus 4, and that would be x is smaller than or equal to 1, right? Now I'm gonna show you how to write a domain. So our domain is, I'm gonna use a pointy bracket and I'll introduce our variable x, and then I'm gonna put a wall here. This is a wall, and after the wall I will put this information in here. So x is smaller than or equal to 1, comma, and now I have to show the type of the number, type of x. X could be any real number. Could be any real numbers. So, have you ever seen this symbol before? It looks like alphabet E, right? But not quite. This is how it should actually look, but sorry about my writing. This symbol means whatever is on the left is in the category on the right. So in our case, x must be one of the real numbers. That's what it means. So as a summary, we first introduce what variable we have here. So in this case, we have x. Then we put a wall here, we build a wall. And after the wall, we start talking about it. So x is smaller than or equal to 1. So we're providing information about x. Then lastly, we also mention what type of numbers this x could be. So domain is like a profile of x. It gives us information about x to us. And yes, for writing a domain, we usually use these pointy brackets. Now we have to show this information graphically. So here's a one-dimensional graph. You know how we normally have 2D graph, like x-axis on here and y-axis like this? This graph only shows one dimension, the x-axis, because we are only talking about x right now. Our domain says x is smaller than or equal to 1, right? And x is a real number. So x could be 0 or -1 or -2 or even 0.5 or 0.9 and etc. So because x is a real number and real number is including decimals and all that, right? Now see how I'm showing it graphically. So I'm going to put a dot here at 1 and then draw a straight line, sorry, this is supposed to be a straight line toward left. And this means we're talking about x which is smaller than or equal to 1. So any region in here. So that's what I'm indicating right now. So any number smaller than or even equal to 1. So here. This is how we show domain graphically. Simple enough. Let's move on to the next question. So it's the same question. Now we have x plus 3 is greater than 0. So it's not greater than or equal to, but just greater than, okay? Remember that. So first of all, we have to isolate x as usual. It's gonna be -3, right? I guess that's it. We can write down domain right away. So pointy bracket, and I'm going to talk about x, put a wall, and then information about x. X is greater than -3, comma, what type of numbers is this? X is a real number. Most of the time, it's just gonna be, this part is always gonna be the same for you guys. So just keep writing this, x is included in the real number. Now we have to show this graphically. So x is greater than -3, right? So I would put a dot here. Okay, that was a bit too big, but yeah, that's a dot. And it should be greater than -3, so I should head toward here, this direction. So this means our x value is greater than -3. But now look at this. In the previous question, I just simply draw a dot here. But here, I've drawn an empty circle, the circle that's empty inside. Why would I do that? That's because we're not including this number, -3. Because you see here, we have x is greater than -3, so it cannot be -3, right? Otherwise, it should have had an equal sign here. In the previous question, we did have the equal sign. That's why I colored the dot. But in this case, we're not including -3, right? So I have to exclude this dot. We shouldn't include this dot. In order to do that, we have to uncolor it. Next question. Write the domain of t and also show it graphically. So now we have t. What should we do now? We have to first isolate by moving -2 on the other side first, right? So 2t is greater than 2, and then we gotta divide both sides by 2, so t will be greater than 1, right? Now let's write the domain. Here you go. Now we have t greater than 1. So what does that mean? We have to make it greater than 1, but not 1. So I'm gonna exclude 1 by not coloring the dot. And then t is greater than 1, so it goes to the right. Next one, write the domain of S. Okay, here we see that we have to flip S, but before that, let's move +1 to the other side. So -S is greater than or equal to -4 -1. So that means -S is greater than or equal to -5. Make sense? And now we have to flip the signs. And you remember when we flip the sign, we have to also flip the symbol like this. So 5 is greater than S now. Make sense? Because we just flip the negative sign and the symbol should also flip. Let's write the domain. Okay, so S is smaller than or equal to 5. Let's show this graphically. So I should color the dot on 5. And then S is smaller, so it should go toward left. Sorry about the line, it should be the straight line. All good. So up till question 4, they were pretty simple questions. Now let's try harder ones, shall we? Okay, now, we have 2 inequality symbols on both sides. So what should we do? We just have to do the same thing. We'll have to get rid of 1/2 that's in front of x, right? So we should multiply all sides by 2. So it's going to be 2 greater x, and x is smaller than or equal to 2. Oh, my bad. 4. Okay, so we just multiply the whole side by 2. Now let's write the domain. Make sense? And now let's show it graphically. Let's do the left one first. X is greater than 2, right? So we should exclude 2 by putting an empty circle. And then it's in between 2 and 4, so smaller than or equal to 4. So I have to color this one. And our x value is in between 2 and 4, so we should draw a line like this. So we don't need the arrow because it's enclosed. So that was interesting. So our x value is in between 2 and 4. That's what it means. Of course, we have to exclude 2. We are going to continue on this topic in the next video. You may go take a break, but don't get too lazy. I highly recommend you to come back for the next video on the same day you watched this one. Okay? See you soon.